Greetings to all. In this video we'll discuss about generic routing encapsulation GRE tunnel. How to create a GRE tunnel, what is the use of creating a GRE tunnel, how to implement in Cisco Packet Tracer tool. We'll discuss about this in detail. Generic routing encapsulation or GRE tunnel is a mechanism which encapsulates one protocol into another protocol and provides connection between the nodes. Basically, it is done over the IP. The main purpose of doing this GRE tunnel is to create a private channel between the source and the destination in the internet, that is public network. GRE provides this communication over a tunnel. This is called as GRE tunnel. This tunnel means that there is a transport protocol and a passenger protocol. Tunnel endpoints know this passenger protocol, but between the endpoints the transportation is done with the transport protocol. So in short, with these tunnels, a virtual network is built over a public physical network and different branches of the same company can able to communicate with each other. Now we can see here the configuration of GRE. It is very simple. To configure GRE, we need two routers that we want to communicate. Once we have these two routers, firstly we need to create a tunnel interface and then we need to add a tunnel IP address to this interface. And this address will be our tunnel's IP address on both ends, and we need a passenger IP address which is called as the IP address of the tunnel, and we need a physical IP address from the source to destination. As we can see from this picture, the physical IP address is the IP address which is given physically for the router, whereas the passenger IP address or tunnel IP address is the IP address which is given to two ends of the tunnel. Now basically where it applies means when we have a company and a person is working from home, when they need to create a private channel between the company and the working environment of the particular person, then there can be a tunnel where the communication is happening over the internet, but there is a private channel between the source and the destination. Now let me assume that I have 192.168.1.network over here and 2.network over here, and R1 and R2 are the end routers. Now if I need to create a GRE tunnel between R1 and R2, I can able to create a virtual channel between R1 and R2, which is a private channel between these two persons over the internet, whereas these routers are still existing in the internet, but the message will pass through this tunnel to the end router. We'll see how it works. Now I have taken two networks, 192.168.1.1 and 192.168.2.1 network. So between these two networks I am going to create a tunnel. So if you see from this topology, if I am sending a packet from 192.168.1.1, it will pass through 11.1.11.11.1, then 11.11.11.2 through 10.10.10.1, 10.10.10.2, then it will reach the destination. This is the original transportation of the messages. But if I am creating a private channel, that is GRE tunnel, between this router 1 and this router 2, I can able to communicate through this tunnel without the knowledge of the main router here. So here what I am taking, I am naming this tunnel as tunnel 0. I can give any name for this one. The conditions I should give the same name. The other side also tunnel 0 I am giving here. Similarly I am giving tunnel 0 here, and the passenger IP address or tunnel IP address on this end is going to be 20.20.20.1, and this end it is going to be 20.20.20.2. So we'll see the commands using the Cisco Packet Tracer tool. On the first router, so I am telling this is my R1 and this is my R2. So on the R1 I need to first interface, that is tunnel 0, this tunnel name. Then I need to give an passenger IP address, it is the tunnel IP address 20.20.20.1 with its subnet mask I am giving. See, this IP address is not the physical IP address, it is only the IP address for the tunnel. Then tunnel source, so this is going to be the source and this is going to be destination for this particular router. So tunnel source I am giving, tunnel destination I am giving. Here one thing to be noted is I can give either the IP address of the destination, or I can also give the give the port which is connected, the interface which is connected. Sometimes it will take either one of this one. We need to accordingly change it, which we need either the destination IP address or the port which is connected. Then tunnel mode GRE IP. Similarly, we can do it on the other side also. Same thing. I need to give interface tunnel 0, IP address of the other side of the tunnel, then tunnel source. Now here this will become source and this will become destination accordingly. Now once it is created on both sides, tunnel is created, we need to do the routing between the tunnel, which means that I am doing a static route on R1 IP route, where this is my destination and this is my next hop IP. So I am giving it in the same way. If you want to learn about static routing, there is a separate video for that. You can learn the static routing detail in that video. Now let us go for the implementation using the Packet Tracer tool. Now here I have created a topology. I have done an OSPF routing. Any routing can be done. Now I have done already routing. Since our concept is only on the GRE tunnel, I am not going to do from the scratch. If you want to know how this has been done, you can watch the video of OSPF part 1. Now from here I am just checking first I am able to send a packet from source to destination. The first packet may get failed because of the address resolution protocol. So second packet onwards it is successful. Let us go and check with the pinging first. Ping, I am pinging 192.168.2.1. It is pinging. Once pinging is done, then I will go with the one more command called as trace route 192.168.2.1. Now I can see the packet is transmitted from 1.1 to 1.100. From there it is 11.2, 10.2, then 2.1. Now let us implement the GRE tunnel between these two. Then we'll check how it is working on. So tunnel IP address, it is tunnel, it is given as tunnel IP address is given. Tunnel is 0 on this side. The IP address is 20, 20, 21. Similarly on the other side it is tunnel IP address is tunnel 0, it is 20.20.20.2. So this is the tunnel IP address. So let us start the implementation. First let me go to the first router, that is R1 router. In the R1 router, first let me change the name of this router, router R1, enable configuration mode. Now I can change the host name as R1. Now it has been changed to R1. Now let us do the implementation. So it is interface tunnel 0. Next I need to give IP address 20.20.20.1 and it's must to 55.0.0.0. Then after that I can give tunnel source 11.11.11.1. So once it is not taking the source, then you can give the port which is connected, tunnel source. The port is SC010. SC010 has taken this one. Now tunnel destination. Destination is IP address of the tunnel. Destination, it is going to be 10.10.10.2. It is up. Now I need to give tunnel mode GRE IP. So when it is done in this end, it is done. Similarly I'll do with the other side. Other side I am doing it now. When I am doing it on the other side, it is going to be the reverse of same thing. Okay, so interface, first let me change the name of this one, host name R2. Now it is host name R2. Next one is interface tunnel 0, the same tunnel name should be given here. The next one, IP address is 20.20.20.2 and 255.0.0.0. then I should give the tunnel source address, tunnel source 10.10.10.2. so it is not taking, you can give the port SE0/1/0. what is that port disconnected? C010, connect only. SE0/1/0. yes. Next one, tunnel destination, I can give the IP address. Done. Once IP address is given, I can give tunnel mode GRE IP. It is done with both sides. I can exit from this mode. Now once this is created, I need to do the IP routing. So I'll go to this router R1. I'm going to give the static IP route. It is 192.168.2.0 network. Then the subnet mask 255.255.255.0, and the next hop is 20.20.20.2. correct. Similarly, I need to do the routing on the other side also. I'll do the routing on other side also. IP route 192.168.1.0, 255.255.255.0. then it is going to be the next hop 20.20.20.1. it is done. Now that's all about the GRE configuration. Now I created a tunnel between these things R1 and R2. Let us verify by sending a packet whether it is successful. Yes, it is successful. Now we'll check how it is working fine or not here. Now this is the original pinging, which is tracing the route from the source to destination. Same command I'm using, you can see 192.168.2.1. now you could see the difference. I'll maximize the screen. See here, it has gone first to 192.161.100, then 11.2, 10.2.1, whereas here from 1.100 it is jumping into 20.2. so here we are able to create a tunnel. Now you can see both. Now we can see here from 190 to 160 to 1.1 it has gone to this routing, it is 1.100. so from here it is directly jumping to 20.20.20.2 and reaching the destination. So in this way we are able to create a virtual channel between the source and the destination very easily. The very much important factor is this GRE tunnel do not support security. So security is very weak in the case of GRE tunnel. So if we need to use this GRE tunnel, we need to go with an IPsec protocol. We'll discuss that in separate video. Thank you.